Good morning, everybody. Now we are going to solve practice problem 3.4 from Alexander Sadiku's Fundamentals of Electric Circuits. So this is the circuit given, and we are asked to find V1, V2, V3 using nodal analysis. Okay. So we have drawn the circuit, and in this V1 is the nodal voltage at first node, and V2 is the nodal voltage at second node, and V3 is the nodal voltage at third node. And here we have 6 ohm, 2 ohm, 4 ohm and 3 ohm resistors are given, and 25 volts voltage source and 5i sources are given, and this is a dependent source. So we have the sources 25 volts and 5i, and this is a dependent source, and these two sources are not directly connected to ground, so they are non-reference, they are connected to non-reference nodes alone. So if you have non-reference nodes, then we can call them as super node. So in the other branches in which no currents are mentioned or marked, we mark the currents. Okay, so we mark the current I1 which is flowing through 6 ohm resistance, and we mark the current flowing through 4 ohm resistance as I2, and we mark the current flowing through 3 ohm resistance as I3. So here we have this problem. In this we mark the currents I1, I2, I3 which are flowing through the resistors 6 ohm, 4 ohm and 3 ohm respectively. We know that there is a super node in this problem. This 1, 2, 3 together form a super node, as they are all non-reference nodes which consist of the 25 volt sources and 5i sources. This is a dependent source. And for this super node, we are going to write the KCL, but for this current I1 is leaving the super node 1, 2, 3, and it is entering the node 3. Okay, it is leaving this first node and entering into the node 3. That means this 1, 2, 3 together are taken as the super node, in which this current I1 is leaving through this first node, and then it is entering into this third node, right? So in total, this I1 current resultant is 0. So this I1 can be ignored. So what are the other currents which are leaving or entering from this 1, 2, 3 node? So if you take this 1, 2, 3 node, the entering current, if you check, there is no entering current. So if you check the leaving current, so the leaving current at this 1, 2, 3 node, they are I, and then I2, and then I3. So these three currents are leaving. So we can write the KCL now. You can write the KCL now. So sum of, according to KCL, sum of entering current is equal to sum of leaving current. So here sum of leaving currents are I plus I2 plus I3, and sum of entering current 0. Okay. So this I can be written as V1 divided by 2 plus V2 divided by 4 plus this is V3 divided by 3, that is equal to 0. So if you take the common denominator, it is 12. So it is 6v1 plus 3v2 plus 4v3, that is equal to 0. So we can write it as 6v1 plus 3v2 plus 4v3, that is equal to 0 into 12. So that is 0. That is our first equation. Now we write the second equation, that is this v1 minus V2, this potential difference V1 minus V2 is equal to, in between you have this 25 volts. So this is your second equation. So the third one is the potential difference between second node and the third node, that is V2 minus V3, that is equal to minus 5i. That is our third. So we can write this I as V1 by 2. So this can be taken as fourth equation. So if you substitute this fourth equation in this third equation, then you will get it as V2 minus V3, that is equal to minus 5 into V1 divided by 2. So it is V2 minus V3, that is equal to minus 5 V1 by 2. So it is 2v2 minus 2v3, that is equal to minus 5v1, or we can write 5v1 plus 2v2 minus 2v3, that is equal to 0. So this is fifth equation. So now you refer this first equation and the fifth equation, because these two consist of three variables. So we can try to eliminate any one variable out of this. Okay, this is our first equation. So I'm going to multiply this fifth equation by 2. That gives me 10v1 plus 4v2 minus 4v3, that is equal to 0. So if you solve this, these two get cancelled. So you get 16v1 plus 7v2, that is equal to 0. Now we can take this as equation number 6. Now you can compare this second equation and the sixth equation. So in which we have v1 and v2 as variable. So now I am going to multiply this second equation by 7. So that I will get it as 7v1 minus 7v2, that is equal to 175. Okay. So when I add these two equations, I'll get this as 23v1 is equal to 175. So v1 is equal to 175 divided by 23, that is equal to 7.608 volts. So we got the first answer. Substituting this v1 value into the second equation, we'll get 7.608 minus v2, that is equal to 25. So minus v2 is equal to 25 minus 7.608. So v2 is equal to minus 17.39 volts. So we got the second answer. This is our second answer. Now substitute this v1 and v2 in the first equation. We'll get this final answer for v3. We'll get the answer for v3. So 6 into 7.608 plus 3 into minus 17.39 plus 4 into v3, that is equal to 0. So 6 into 7.608, that gives you 45.648 plus 3 into minus 17.39. So it is minus 52.176 plus 4v3, that is equal to 0. Minus 6.518 plus 4v3 equal to 0. So v3 is equal to 6.518 divided by 4, that is equal to 1.6325 volts. So we got all the three answers. So now we got the answers. v1 as 7.608 volts, v2 as minus 17.39 volts, and v3 as 1.6325 volts. Now we'll check back our answer given in the problem itself. v1 we got the correct answer, v2 also we got the correct answer, and v3 we have a small difference, right? It is 1.6325 we got. Anyhow, it's okay. Thank you.